Our thesis is entitled Students' Executive Function Assessment Tool Using Convolutional Neural Network. These are the recommendations of our panels through the nature of revisions. We've addressed it by correcting the format of our tables, revising our second objective into monitors heart rate variability, changing the condition from one of our flowchart, removing unnecessary parameter stat treatment, providing training procedure and data structure by adding data augmentation, and lastly, including data gathering procedure for image gathering, validation, and images. Introduction. Executive function and academic stress is a psychological factor that affects the mental process of human beings. Problems regarding those two can negatively affect someone's mental development. Using neuropsychological tests while measuring heart rate variability to classify their emotion and neural network to classify their facial expression, this will help assess and detect executive function and academic emotional stress. Statement of the problem. Lack of reliable systems developed to diagnose possible problems in executive functions through technological means. Since commonly used methods for the diagnosis of this problem, such as anxiety tests and achievement emotions questionnaire, are often multifaceted and easily hoaxed. These are the objectives. The general objective is to develop a device that could help psychologists, counselors, and teachers determine where the patient or children is having difficulty in terms of executive functions and classify any academic stress. The specific objectives are first, to create a prototype using neuropsychological tests that will output an assessment report on the three areas of executive functions, which are working memory, flexibility thinking, and inhibitory control. Second, monitors heart rate variability. Then lastly, use a neural network that will determine the presence of academic emotional stress.
So here's the scope and delimitation of our study. The scope of the research focuses on serving as an early warning system for students and children in determining their executive function deficiency. Note that all measurement tools used here, such as the ECG signal, will not be used or must not be used in any medical assessment whatsoever. The assessment will be done using neuropsychological tests, software-based games, pulse rate measurement tools, and neural network for facial expression recognition. So the neuropsychological test will be our basis or the validation data in determining if they are lacking or is in great deficiency of the three skills mentioned in our study. The software-based games will be our tool in measuring their level of their three executive skills, and the pulse rate measurement tools will be used to validate their emotion via their heart rate, and the neural network facial expression will be used to determine their facial expressions. The delimitations of the study are: it will only focus on the detection and assessment of executive function and academic emotional stress. So our study is limited in those two criteria, and that any other means of sickness or mental issues will not be validated and will not be considered here in our thesis. Since the frequency domain test computes for the R peaks of the ECG waveform, the length of the ECG signal must be greater than 10 in time, or else the data analysis will not have sufficient data for it to perform spectral analysis, or in other terms, the LH ratio. The test subject for this study will be in any demographic of age group, with the exception of suffering from ADHD or brain trauma, or any other medical sickness such as in the heart or in the mental state.
Significance of the study. By automating the diagnosis of the possible problems in executive functions, it will benefit the following: psychologists, counselors, teachers, and students. Let's move on to the methodology. This is the conceptual framework. It shows how the process works in determining the presence deficiency or healthy in executive function, and also the positive or negative academic emotions. The inputs are the game choice, facial recognition from the input image for the convolutional neural network, and the ECG signals are the output of the ECG device that is gathered from the testing subject's heart rate variability. The process is the convolutional neural network will utilize an edge detection algorithm into the image that uses real value parameters and binary parameters for maximum accuracy. For further verifications, the coefficient of variation of error intervals, or CVRR, and frequency domain analysis is used to determine the emotion of the testing subject via heart rate variability using ECG device. This process will output the presence of positive or negative academic emotions. This is the main flowchart. First, it initializes the game choice, facial image, and heart rate. Then it will go through the three modules, which are the emotional classification process, ECG analysis process, and display assessment process. For the emotion classification process, which is the convolutional neural network face recognition process, it will first initialize the image, then resize the image, then it will apply the convolutional neural network that utilizes the edge detection algorithm into the image that uses real value parameters like eyebrow raise, and also uses binary parameters like for the nose line. Then it will classify the emotion recognized in the input image. Then the final expression classified by the combined neural network is displayed and the process terminates. Next is the ECG analysis process. First is obtains the sample, wherein the ECG devices measures the heart rate of the testing subject at the entire process of the game. It will analyze the data by time domain analysis and frequency domain analysis. Then through digital filtering, it is used for pre-processing of ECG signal before peak finding. It is designed to have a frequency response as flat as possible in the passband to remove unwanted noise and signal. Or peak finding is used to determine the error intervals that will be used in computing the CVRR, and also the spectral analysis, which is the LH ratio. Then it will output the emotion recognized by the ECG device. Then it will return to the main system flowchart. This is the architecture used for the convolutional neural network, or CNN. This is the CNN model. To obtain the CNN that can classify the emotion of a person based on an image, the given process is used. First, data shall be gathered in the form of images, which consist of images taken from human faces, that showcases the different emotions such as happiness for positive emotion, anger, fear, sadness for negative emotion, and also neutral emotions. This data shall be split into training and testing datasets. The training dataset shall be used to train the CNN until an acceptable accuracy is obtained. After training, the CNN model is validated using the testing dataset to determine the overall accuracy of the trained network and describe how well the network performs in classifying the emotions of a human from the input images. This is the block diagram of the system. For the hardware, a smartphone and an ECG device is connected to the ESP32 or ESP8266 Node MCU wireless transceiver. The Node MCU will be responsible for determining which data came from what wireless module and will create HTTP requests to the web API from where the data will be stored. A Wi-Fi module will be used to allow the Node MCU to communicate with the web API, in which the web API will serve as the communication bridge between the hardware and the software. All the data collected from the Android device's games shall be saved to the database and processed by the web application created. The convolutional neural network based on TensorFlow and Keras will be executed in the server to determine the emotions from the given images. The node MCU will be responsible for determining when the sensor nodes will acquire and receive the ECG signals and game results, as well as sending it to the server and towards the database. From the stored samples, each sample will be retrieved and will be sent to the server. Then, it will be removed from the stored samples. This will continue until all samples are sent to the server.
So here's the resulting discussion that we conducted in our thesis. Note that the age demographic here of our thesis consists of young adults such as 18 to 28 years old. Our emotion was categorized in three ways such as positive, negative, and unknown. Positive emotion being the ones that are positive such as happy, neutral, etc. While the negative emotion are the ones that are the negative emotions such as fear, angry, and sad. Unknown are the emotions that had no classification in our category whatsoever. So the trials that we conducted 14 trials, and due to the current state of the pandemic, we couldn't access more without risking any health condition, and we don't want to violate any social distancing laws here in our LGU or in our region. So the actual emotion are the emotion that the respondents told us after conducting the testing. So we asked them what they're feeling, and this is our result that they given. While the machine prediction emotion are the ones that RCG, ECG classification and emotion recognition via CNN has outputted. So table to explain the predicted emotion compared to the actual emotion. So here we are able to determine how accurate our testing was, and here we are given 4 for positive, 2 for negative, and 2 for unknown. While the false prediction were 2 for negative, and 3 for unknown, and 1 for unknown and negative. Adding this up, we were given 8 over 14, thus give us the accuracy of 57.14%.
Since emotions and psychological tests have been an important factor to further understand humans' mental health, this study demonstrated how emotion recognition via an input image and heart rate variability can determine a person's cognitive development. So in our findings, despite having a limited testing subjects, 57.14% accuracy of emotion recognition was still acquired by using time and frequency domain analysis. Next, the accuracy obtained through the ECG analysis is 57.14%, which was obtained through the calculation from the results on Table 2. Then, games were used to determine the level of working memory, which is the ability to obtain an information, flexibility, which is the ability to provide solutions to different problems, and also self-control, was similar to the result on the neuropsychological test. Lastly, the researchers were able to determine that negative emotions tend to decrease the cognitive ability based on the results from the games and also the neuropsychological test. The researchers recommend using other algorithms to classify emotions through ECG signals. This will help further increase the accuracy of the result. Then, detect more emotions besides the happiness, anger, fear, sadness, and also neutral. Use more practical ECG sensor that can measure V1, V2, V3, and V4 to provide more parameters for emotion recognition. Then lastly, to have more testing subjects. And that's the end of our presentation. Thank you.